Hi, so this is February March 22, paper 42, question 2. So, firstly, as you can see, we have a Carnot cycle, right? And they have given you a table as usual, which we need to complete. Okay, so for the first part, they had asked us to state the change in internal energy, which for a Carnot cycle is always zero. And then they have asked us to calculate the amount N of gas, which we know that we can easily calculate using PV equal to nRT. For the first column, for X, you can see we do have the pressure, the volume, and the temperature. So what we simply need to do here is input in the values. All of the values are in SI units, so we wouldn't have to convert as well, just need to input values and calculate. Alright, so my answer is 0.14 mole for this part. Now let's move on, and the part is now asking us to complete the table. Okay, so because X and Y are on the same level, so the pressure is going to be the same, that is 1.5, right? Because pressure is on the y-axis. And for volume, we can calculate because we now have the number of moles, and we know the pressure, and we know the temperature, and we already have R, right? So that came as 2.7. So as you can see, the power 10 into the power minus 3 is already written, right? So I just need to add the 2.7 part, right? So I'm gonna calculate for the last column as well in the same manner. I'm using the equation PV equal to nRT, and my answer is gonna come as 1.8 exponent minus 3. And as I did for the column before, I'm gonna just add the answer, right? Then they're saying the first law of thermodynamics for a system may be represented by the equation, right? And then they're asking you with reference to the system what is meant by. Okay, so here you need to be really careful. You need to write according to the sign, right? So because it's positive Q, I wrote heat added, and because it's positive W, I wrote work done on gas. If it will be negative W, then it will be expansion, so work done by gas, right? So just some things to be careful about. Okay, so for the last part, explain how the first law of thermodynamics applies to the chain Z to X. So we know that overall there is no loss in energy, that is conservation of energy, and that is the first law of thermodynamics. That heat can be added or removed, work done by gas or work done on gas, but the overall energy change is gonna remain the same. It's gonna return to the same point, and